Okay, good morning, Yancy and fellow learned colleagues, and thank you for this opportunity. I'm going to try to make this not too serious, but enjoyable, that we could take away a lot from what we're doing around the surveillance aspects. So if I can just get to share my screen. Great. So, I was asked to talk about what we're doing around wastewater in general in responding to the COVID issue and widen it to many other epidemiological activities as well as chemical stuff around surveillance that we've initiated in the WRC towards supporting national efforts. Now, the fun part of it is that my boss always tells me I start with the most lousiest slide, that puts people off. When we talk about human waste or feces or call it shit, etc., it must be really ugly to other people or many people. But for me, it's a treasure trove of health information and knowledge. And we're beginning to learn and about this more and more every day. And the COVID has actually given us that opportunity around, the whole wastewater-based surveillance angle. So, what can wastewater-based epidemiology reveal for us? And we've been doing a lot of work, and we're seeing a lot of opportunities with the emergence of a number of pharmaceuticals and other substance uses, etc., illicit drugs in the system, diets and genetic markers and biomarkers. So we're starting to see a whole range of opportunities of once, an area that was just considered as waste started to see as a resource of information and knowledge that puts us in the forefront of managing, epidemics and all sorts of diseases in society that are emerging. Okay, so where do we see this opportunity of use of this environmental disease surveillance data? And the opportunities are opening around, determining general pathogen circulation within populations through qualitative analysis, establishing trends or changes in the number of disease incidences, and that links to characterization and the number of infections in communities, and tracking the number of infections and the disease burdens that we were able to map and model, the hotspot areas and the hotspot incidences into the future, okay, providing a full spectrum of even going down to the level of genetic diversity of these pathogenic strains and changes and many other aspects. But also, assessing occupational human health risk that people are generally exposed to. And I'll share some of those kind of things we're looking at in this. So this whole issue of environmental surveillance, specifically from a water and a wastewater-based bias at the WRC, fits into our general water quality, sanitation, and health program. And, a few years back, we already identified this as a strategic area. We needed to build research capacity and long-term research knowledge that influences the sector to start adopting environmental surveillance from the water and wastewater side as not as a nice to do, but as a have to do, okay? Based on the kind of strategic relevance and the economics and the value it offers. So this just gives you a kind of broad understanding of our strategy around, building this national wastewater surveillance platform for various pathogens and chemicals, etc., stimulating the research pathways, and then the transmission and preparedness of this. So this is the broader WRC strategy, and COVID just came in and accelerated what we wanted to do in terms of driving this platform and the urgency of this platform. Now, I'm not going to go to this for people around this audience, they're quite aware of the presence of SARS-CoV-2, but to reiterate that the risk of transmission of the virus from feces of an infected person has shown to be very, very low to negligible in the water environment, especially when it's excreted through the human gut, etc. So we don't have huge concerns on that aspect. And that is what we're finding in a lot of the work we've done around testing some of the wastewater samples, that we're not finding any live viruses per se in the systems. So the focus of it has been largely around looking at the RNA fragments as a marker in terms of wastewater, specifically for the COVID-2 RNA, and the sort of area was sort of raised interest very early during the outbreak by the Dutch through KWR, that published the first papers around them picking up the RNA signals in wastewater. And of course, you know, the whole world went crazy to say our wastewater is contaminated, this virus is live in our system, etc. But I think the media did not pick up, you know, very clearly that we're talking about RNA fragments and not live viruses. And to share with you how we've structured a lot of our work around this. But the Dutch have been instrumental over the time to track this quite in detail and align it to the number of cases and the lockdowns, etc., to show that this monitoring affords an early warning system that allows authorities to start preparing and managing as a complementary to the health interventions that are there as well. So it's not an exclusive, but it helps. It's a lot more cheaper, and it's a lot more faster and effective. And it's able to pick up a lot of the asymptomatic individuals in your population as well. So you get a more fuller picture of what is happening in the population.
Mr. Bhagwan,
yeah.
I'm not sure if your slides are progressing. We are on slide 4. Are you still talking to it?
It's progressing on my side. I'm going to go out again and come back in. Let me try that again. For some reason, could be the...
Ah, there it is.
Okay, it might be the bandwidth is quite slow. So what we know is that, you know, countries like the Netherlands have taken this at a national level, and they've passed policy decisions to ensure that all 352 wastewater treatment plants are, you know, sampled for SARS-CoV-2 virus and contribute to the national dashboard. And they're using it very effectively as a complementary, like I said, a complementary data and support around the whole health systems and the cases. And they're finding a lot of synergies and greater value from a cost perspective in doing that. We're still playing catch up in South Africa because I think we're still overwhelmed by the vaccine and the case study kind of dogma. And we're not looking at, from the health sector, at, you know, picking up the low-hanging fruit and running with it. So, you know, that's the criticism from my side around that. So the WRC approach, we took a three-pronged approach from you know, the international experience, and what we're seeing is that the communication was very, very important. You know, we didn't want to scare people that they would run, you know, under the shells, etc. Especially there's concerns around the virus being in water supplies, and all those kind of things started to become quite a concern. So we needed to get the communication aspect, and we built a lot of communication instruments that we communicate the science and the information more accurately to the wider population. The second part was to build and establish this wastewater surveillance platform for COVID-19, and then also to stimulate the research and development with a little bit of acceleration. And I will share with you, you know, some of the activities we did. So our national surveillance program, we sort of organized it around 3 levels, and the first phase was to very quickly do the proof of concept, establish the methodologies that work very well for us through this process, but also organize the cohort of laboratories and people that can do this stuff, because at the moment, one of the limitations are that a simple testing for a virus RNA is restricted to certain levels of laboratories. So municipal laboratories cannot do this. And that's one of the biggest hurdles in the system that we need to unlock, okay? So we needed to get which labs were accredited, who had capacity to accommodate us, and those kind of things, and then also work out the logistics of how we're going to move samples around the country during a lockdown period as well. And we're now into phase 2, where we're starting to scale up this and getting this logistic model to work that organizes for us to send the signal to the national authorities to say, guys, this game is for you all to take over. We're just fueling the platform. This is where surveillance should sit at a national level. And we've just sort of established and greased the system for you to take it into your strides in the system. And we're waiting for that signal to come from the Department of Health and Water Affairs and COCTA and those kind of things. What we want to see as outputs and outcomes is to build through the scientific platform, the interlab proficiency, the data integration and trends, establish the networks. As outcomes, establish the platforms for the heat maps, the institutional partnerships and the strategic partnerships, and get to a point where on the longer term, we have a platform for an early warning system that offers platform for many other pathogens and other diseases to come into this water quality surveillance system that will benefit the country. So this is the building block and the acceleration pathway towards a longer term surveillance platform, a wastewater and a water-based surveillance platform. What's unique with us is that we got thrown into the international community. So South Africa is regarded now as leading some of the scientific developments in this area. And while the developed world were just looking at wastewater, we had the unique challenge that the dichotomy we live in, a large percentage of our population lives in non-Seward areas. And we also took on the challenge to develop a non-Seward surveillance program. Okay, and I'll share with you the kind of things we experimented with and what we're looking to take forward. So, the planning, like I said, it's all about logistics. The science is there. It was just about applying it, and it's getting all these elements around the sampling, the testing, and the data and the communication all aligned adequately. I'm not going to go through this, but just to take you into the proof of concept very quickly, is that it was a 6-week study, and we wanted to get to this answers very, very quickly. So we launched the study with the University of Pretoria and several others, picking 24 sites in the hotspot areas in the first wave, Cape Town, Durban, Ekurhuleni, etc. And we also divided that, 24 sites into 6 different typologies. So we looked at hospitals, we looked at industrial sites, we looked at mining sites, we looked at non-Seward areas, informal settlements, etc., across 5 provinces and 10 districts. That was the first round, and of course, we use the amplification of the CT values as a mechanism to show the presence of the RNA, in the samples we were testing, to make it quite easier to convey. There's a lot of science behind it. I'm not going to go through all of that detail, but just to get the message across and explain to people that the CT value is the amplification of finding, and the stronger the amplification, the more the presence of the RNA. We didn't get to quantification yet because we needed to develop the methodologies, and we're busy with that, but that would, in the second phase, be one of the features that we're able to identify the presence of RNA, but also quantify this to the number of cases we possibly can detect. So we're using the polio methodology at the moment, but we're adapting that to the kind of control systems that we put in place for research around the COVID-19 virus. So just some over the 6 weeks, you'll see that, while we were in that peak, in Gauteng and KZN, of the treatment plants we were taking samples from, and you could see that we had a positive result for most of the samples right through the 4-week period, in all provinces. And it was obvious because it was the hotspot areas. So if we didn't get it, we had a problem with our methodologies and our techniques. So this is starting to show that the methodologies and the techniques we were using were working. And these were against huge challenges where people had to innovate a lot because the access to the kits and that was a premium during this period to undertake the wastewater-based thing. So we've come up with a lot of methodologies and tools, and we've published that, for public consumption, because we've developed a whole lot of novel techniques in South Africa that are very, very localized using local products as well. This is the Western Cape, and you could see that, over the 4-week period, also in the Western Cape, we picked up the signals quite significantly and quite strongly in the hotspot areas that the Western Cape was identifying. And we did some kind of ad hoc things to try to map these signals to the what you would call the caseloads that were being reported in these towns and cities. And we could see a lot of synergies with the signals and the case loads increasing and decreasing over the 4 weeks. So that was telling us that, the technique and the method can be used for monitoring the trends, and possibly then with the quantification and more work, we could get to this point of heat maps and early warning systems. So that's just in Ekurhuleni and Gauteng and Tshwane, giving you an indication of how the green line is the caseloads from the Department of Health in each of the cities, and the different treatment plants, as the CT values go lower, it's showing that the signal is much higher, that there are much more larger cases in those areas being served. And, we then took grab samples, just one, to look at what was happening in prisons, because they have large populations and they have their own treatment plants, okay, and certain big industries, because the concern was that they have a mobile population going in and out of the facilities, and they wanted to get a sense of what was happening in their own systems if they were to adopt this. And the same with universities and many other larger facilities. And you'd see that we were able to also pick up signals in one of the industrial centers that employs about 4,000 people, and one of the large prisons on the outskirts of Gauteng that was already showing that they had a number of cases identified in the prison. So that showed us that the system does work in those areas. And we took a power station, I won't say which power supplier in the country, because they also employ large workforce in one of the mining houses in the country. And you'll see that, in the Mpumalanga and the Western Cape, we found positive RNA detection in also the population that comes to work. Of course, it was one grab sample, but we wanted to get a quick answer on that. We went further on the non-Seward areas, and we took, in Alex and the Jukskei River, we went into the community, and we took the water standing in the community because they don't have drainage, etc. They have water supply. So a lot of the runoff in the community, we took the runoff just leaving the community, entering the streams, and we took the samples in the streams. And what we found, which was unusual, we didn't expect it, that we found the RNA signals also present in these wastewater, in the water streams. So it's told us that it might be a technique we can use, but we may not be able to quantify, but we'll be able to quickly identify that there's a increase in caseloads in those communities. Okay, and it helps a lot in terms of complementing the response issues in those areas. We have this report out, on the proof of study that we've published, and it's available, and it's got a lot of scientific elements to it, and it'll appeal to a lot of the scientists. And like I said, globally, there's a big appreciation for us sharing this, kind of work and what we're doing around the methodologies and the approaches we've been using. The second phase we launched into is, we call it the pilot phase, but all we did is that with the first phase, we're able to get the community of practice together. So we now know which labs are available between the public and the private sector and what capacities they are and how they can organize themselves in terms of serving a broader network of 896 wastewater treatment plants in the country. Not all of them, but most of them. So we've partnered with the NICD, and from the process, we've also created a national platform called Success. It's a South African collaboration community on environmental epidemiological surveillance. And it's made up of universities, metros, some of the science councils, etc. And it's a voluntary network that comes together, shares methodology, shares experience, and shares data. So we've appointed NICD as a strategic vehicle because we see NICD's mandate to organize the South African sector on the long term around the broader surveillance pathway. And this is our contribution in establishing that platform. And NICD has also been working on the WBE stuff, from the early listing. So we're able now, right from the beginning of the pandemic, able to develop the spreadsheet of all the sampling and the results we've been collecting. And what you see is just a dashboard around the red being all the positive cases of all the treatment plants we've been monitoring, right from the beginning, till somewhere this graph goes on, or this spreadsheet goes on to somewhere around end of December, etc. But NICD has a more live web sheet on their website that we keep updating. And the next phase is taking this information, putting it into a GIS platform, and then starting the quantification aspect. And we now brought this community of practice together, and we've scaled up from 25 sites to nearly 70 to 80. And as we get more resources, we're trying to scale that up even further so that we get more treatment plants into the loop. Sadly, the Western Cape, or not sadly, but the Western Cape has taken the leap in using this, and you've seen reports that they have integrated the wastewater surveillance system into the national health system at a provincial level. Unfortunately, the other big metros and them have not even started and considered anything. They just haven't gleaned on this opportunity that makes more economic sense, in terms of honing down to the areas that will be very, very problematic and require the health intervention. So it's something that's a concern to us, that where the big problems are in the metros, etc., they're very slow to start leaping into this opportunity. Some takeaways, from what we're learning, and like I said, that we've through MRC developed the first wastewater sampling guide, and then we've also developed a compendium on testing methodologies, in the laboratory. That's out in circulation. The science and the techniques keep improving. I mean, we have a fantastic community that keeps pushing the boundaries under the constraints that they faced with. The challenge is to bring the cost of testing and surveillance even lower. At the moment, a large part of it is the logistics because of the lab issues. We have to courier stuff around. So the courier costs are quite high, but we're seeing anywhere, if we're able to get to a lab nearby between 1,000 to 1,500 for a sample, and if you do it once a week or even twice a week, it's more cost effective than doing individual clinical testing it's much more effective. We're busy with interlab testing validation because now we have all these laboratories performing and using similar methodologies and results, so we're able to do a lot of validation. There's also some of the research issues. I mean, influent variability and temperature and those kind of things are things we have to also research and test and see how it influences what is happening, in the systems. And, we've seen many countries and institutions already adopting these things at a national level, okay, and using it as a complementary activity. In ending, we haven't only done that. I mean, we've at the WRC opened pathways of the surveillance on many other water disease surveillance techniques. We've got programs at a research level that looking at the pathogenic bacteria, the diarrheal and the E. coli and the cholera and the salmonella stuff, etc. We're also looking at the enteric viruses surveillance and also the protozoan stuff, etc. So that is a smaller initiative, but this impetus, affords us to scale a lot of that knowledge that we are generating. And, the AMR and the antibiotic stuff is one of our larger focus points at the moment that we have programs with a number of institutions in unlocking the knowledge base towards the surveillance aspects. What we've also done is, and demonstrated some of the chemical elements and monitoring of that. So if you live in Cape Town and you take a lot of cocaine, you'll be aware that Greenpoint is a hotspot area. So we've demonstrated the use of and abuse of narcotics in these areas, etc. And we've demonstrated that it can be used as a surveillance technique, and you can pinpoint it down to which catchment and which area is generating a lot of this narcotic substances. So it helps in the fight against drug abuse, etc., especially in the Western Cape that keeps complaining about drugs and those kind of things. So here's something that we put into effect in terms of the surveillance program. Yeah, I'll stop there just a very quick, input into the variety of things we're doing. Just to close, we have initiated studies around the genomic aspects and trying to pick up the variants in the wastewater samples. What we've seen from the research that the wastewater sampling gives you better signals for COVID than taking the throat and the nose sampling, etc. It's just that it's a difficult one to administer. So it's not practice, but what we're seeing from the research, etc., that a swab through the anus, etc., or a fecal sample gives you better indicator of the presence of the RNA virus in a human being. Yeah, so there's lots of things happening, and like I said, that we're building the knowledge base, and we'd welcome a lot more partnerships and collaboration, and anyone that can help us to take this platform even higher, because it's a more longer-term goal that we're trying to get to. Thank you very much.
Thank you very much, Mr. Bhagwan. That was fascinating. And it's so important because there is a lag due to the asymptomatic nature of many of the cases. There's a lag in identifying that there's an outbreak. So this would be more efficient in that sense too?
Yes. No, that's what we're finding, that as you start relaxing the lockdown levels and get the economy going, it's going to be cost effective to start monitoring the economic population as well, because they're coming in and out, into different catchments, etc.
Right.
So it's going to become a very useful tool for employers, for institutions, etc., to manage this pandemic and create awareness.